Hello everyone, and welcome to today's iTwin Platform Developer Webinar. My name is Jason Slocum, and I'm part of the product management team for Bentley's iTwin Platform. Today, I'm thrilled to be joined by Travis Cobbs. Travis is a principal software engineer for the iTwin Platform, and he's going to show us how to create an iOS app using the iTwin Mobile SDK. Travis is going to start by walking us through how to set up the Swift and NPM packages, and then demonstrate the steps needed to integrate the iTwin Mobile SDK into an iOS app. Please be sure to post your questions in the Q&A widget you see on screen, and we'll have some time for answering your questions at the end of Travis's presentation. Before I hand it over to Travis, I wanted to provide you with a brief preview of the iTwin mobile app in action. If you are at all familiar with the iTwin Viewer template for building web applications, then what you are seeing on screen should look pretty familiar. The app starts on a home screen where you can choose to either connect to a hosted iModel, or you can select to open a locally stored iModel for offline viewing. Once you select that iModel, the viewer is quite similar to the web application. You can view the model in 3D, and you can interact with it using standard iOS interactions to rotate, zoom, and pan your model. You can also select elements and get all the property information for them. One thing I'd like to point out is that what you see on the screen is actually running on an iPhone SE, and this is one of the smallest displays you're likely to encounter on an iPhone. During Travis's presentation, you'll get to see how this scales to work on an iPad that has a much bigger screen. Now that you've got a glimpse of what the iTwin Mobile SDK looks like in action, I'm going to turn it over to Travis, who's going to walk you through how to get started using it for your own app development. Over to you, Travis.
Thanks, Jason. I'm Travis Cobbs. I'm a developer on iTwin Mobile SDK, and I'm here to talk about that SDK and more specifically show you one of our simple sample apps that runs on iOS. So to show you how you can use iTwin on an iOS device. The iTwin Mobile SDK is a mobile SDK built in order to allow you to use the iTwin platform in your native mobile apps. The iTwin platform itself runs in a web view, so the mobile SDK is set up to do that, so that when you're running on iOS or Android, you create a web view, and then all of the iTwin stuff runs inside it. Usually in TypeScript, although you can use JavaScript. The SDK is designed to be used with TypeScript. This here is our iTwin platform page on GitHub, and if you search for mobile on the list of repositories, you will see the 7 repositories that make up the iTwin Mobile SDK. The first repository here is Mobile Samples, which is where the sample that we'll be showing you today is located. Then we have Mobile UI React and Mobile SDK Core. These are both NPM packages that you use on the TypeScript side of things. Then we have Mobile SDK iOS. This is a Swift package, although it's also available for CocoaPods. And you use that on your native side of things. And then we have Mobile Native iOS, which is a dependency of Mobile SDK iOS that you don't have to access directly, but which will get installed when you install this. And then we have 2 Android packages that we're not going to be talking about today. If we look in Mobile SDK iOS, it's a Swift package, and it has a README that talks about it and gives you information. And before we actually get into the sample, I'm going to real quickly show you how you would add this to your iOS project. To do that, you go in here, copy the Git URL, and then I have a project that I created in Xcode that doesn't have anything in it yet. It's just a new project. And in the project, you go to the project itself in the navigator, over here you select the project instead of the target, and then under package dependencies you want to add a new package dependency, and then you paste that URL that we copied before into the list. And then very importantly, you need to use an exact version, because the Swift package is tied to a specific NPM package. And I showed you those NPM packages before, and well, all the versions have to match up in order for things to work correctly. Then you hit add package again, and it adds the package to your project. Now, when you do this the first time, it'll take quite a lot longer because it has to download these packages, and some of them are kind of big. But anyway, that's all that's needed to get started as far as making use of it. Going back to here, the mobile samples project repository, is where we have the various different samples. As I mentioned, there's Android, but we're not going to talk about that. And then there's iOS. We have a number of samples. The two most simple samples are Mobile Starter and SwiftUI Starter. Both of those are just simple full screen iTwin mobile apps. One of them uses UIKit and the other uses SwiftUI. Because they're full screen and they don't do anything, there's really not a whole lot of difference between them. Obviously, the setup is different for SwiftUI versus UIKit, and that's the whole point of the samples. And then there's some other samples that we're not going to talk about. If we look at the README for the iOS, it has instructions on how to set things up. And it starts out by talking about the fact that you need to use the same version across all of them. And then it talks about the fact that you need to set up your client ID. Now, the reason for this is that the iModel Hub only works with iTwin apps that have been registered with Bentley. And so in order to do that, you need a client ID, and then the application also has a scope, which basically talks about the various different permissions that the application needs in order to function. So we have instructions for creating a client ID here, which I've of course already done. And then we have instructions on creating a file named inetm application.xconfig. And if we look in the Xcode project, this is the mobile sample Xcode project. And we can see here we have an itm application.config. I'm not going to show you the file because it has my client ID in it. We also have iOS samples.xcconfig. This iOS samples.xcconfig is part of the repository. itm application.xcconfig is in the gitignore for the repository, and you have to create that file. And inside here in iOS samples.xcconfig, it talks about all the various different settings you can put in this file. Now, an xcconfig file in Xcode sets environment variables that are available at build time. And if we look in this sample and look in its build phases, we can see we have a copy web app assets, and that calls this shell script. And if I bring that shell script up in Visual Studio Code, cd iOS, and we look at copy web app assets, this is that shell script, and it does a few things. It calls this itm app config, which I'll explain in a minute, and it copies the assets that are needed in order for the web app to function. So what this does is it pretty much takes we have a React web app that will be running inside the mobile app in a web view, and this copies that React app into the web view. Gen itm app config, what that does is it makes use of the variables that are set in here in order to generate a JSON file that also gets copied into the web app. And that JSON file's name is itmappconfig.json, which is why that was the name of the script. Now, this sample app, as I mentioned, is quite simple. If we look in app delegate, we'll see that it's just the default stuff that's generated by Xcode. If we look in scene delegate, most of this stuff is also the default stuff that's generated by Xcode, but we did plug in some stuff into the scene we'll connect to function. Specifically, we configured a view controller's application object, and we set this flag, which isn't really important right now. The view controller's application object is obviously used by ITM view controller, and you might ask, well, what is ITM view controller? Well, if we look in the main storyboard, we can see that our view controller here for the main storyboard is ITM view controller. We also see that that's all that's in the main storyboard. The whole thing is just a full screen view controller, and it's just ITM view controller. ITM view controller is designed for you to place in your app anywhere you want to show the iTwin web view, and in this app, that's the whole thing. We also saw that we set the application object on that to model application. So ITM view controller is expecting there to be an application, and you have to instantiate that. In this case, we're using model application. And if we look at model application, we see that that's a subclass of ITM application. Now in the view controller itself, the application object is of type ITM application. And then we're using a subclass that has our custom one that overrides a little small amount of stuff in ITM application for our purposes. Looking at this model application, we can see it in our initializer. We call super, and then immediately we do a few other things. The first thing we do is we set the logger. ITM application has a default logger that it uses nslog to log stuff. That includes console messages from the JavaScript, because by default it redirects the console messages to the native code, and we have that. You can also manually call the logger, plus if certain errors appear, they'll go through the logger. Now, the default logger, as I mentioned, uses nslog, and as you may or may not know, nslog truncates all log messages to 1024 bytes. So we have a super simple logger here that is just for demonstration purposes that we use print from Swift instead of nslog, and print does not truncate to 1024 bytes. So this is here mainly to show how you would do your own logger. You could have it do whatever you want. You don't have to be printing it out to the console. You can, of course, actually be logging it somewhere. But this is just a simple one to show what's going on and show how to replace ITM logger. Then we have these register query handlers. These are functions in ITM application that make use of a class that we have that's called ITM Messenger. And ITM Messenger is used to communicate back and forth between native code and TypeScript code. And so here, the register query handler is saying that when the TypeScript code asks us to do these things, this is what we'll do. This first one did finish launching, is to let the ITM Messenger system know that the TypeScript is done configuring itself. What that means is that it's ready to receive messages. And the only thing we do in this is we tell the messenger that the front-end launch has succeeded. Until we do this, it won't actually send any messages to the TypeScript code. And the reason for that is because if you send a message before the query handler's been registered on the TypeScript side of things, then the message is ignored. So what happens before you sent this is that the message is basically put in a queue waiting for this to be called, and then when this is called, it will send those messages through, any of them that have been queued up. We also have a register query handler for loading, and you can see all it does is it sets the web view to not be hidden. So in many times in your app, you'll want to interact with iTwin using Messenger to send queries to the TypeScript code, but you won't want it to actually be visible. And so it starts out with the web view not being visible. And so as soon as it gets this loading message, it sets is hidden to false, so the web view becomes visible. On the TypeScript side of things, loading is actually sent immediately after the messenger class is initialized on that side. We also support reload, although this sample doesn't ever actually call that. And then we have this get bim documents. And what this does is it returns an array of paths to all of the star.bim files that are in the application's documents folder. And the application's info.plist has been configured to allow you to put documents in there from like Finder on the Mac or iTunes on Windows. And then the last thing it does is deal with Showtime. Showtime is a Swift package that we have in this, and all it does is it lets you see where people have tapped on the screen. It's useful for when you're doing presentations. And we have it default to not being enabled, but then if one of the settings in xcconfig is set, then we enable it here. And in fact, that setting is set in ours. That's the end of the init function, and then we have view will appear, which seems a little odd since this is not a view controller, but the ITM view controller calls view will appear on the ITM application. So the first thing we do is we call super, and then the next thing we do is we register one of our components, which is the document picker. And the document picker is an ITM native UI component. ITM native UI components are used in iTwin Mobile SDK to allow you to have native UI be shown from your web UI. So the basic gist of the native UI component is that it has a view controller. As you can see here in the init, it has a view controller, and it has a messenger. And the view controller is used in order to know where to show the UI, and the messenger is used to communicate back and forth with the TypeScript side of things. And it also has a query handler, and the query handler is basically what you use in order to communicate with it. So in this case, we have the query handler of choose document. So when the TypeScript side of things sends a message called choose document, it will go into our query handler here, and this is the query handler, and it's kind of complicated, but what this particular object does is it uses the iOS API to allow the user to choose a document from the iDevice, iPhone, iPad. So for example, you can pick out a BIM file from inside of OneDrive or Dropbox or something similar. Finally, we have get URL per hash params. When the web view is loaded, it's loaded with the URL, and the URL includes a hash, and then after the hash, it has various parameters, and those are designed to allow you to send information in. So we have two sample-specific hash params we support. We have debug IATN, which will put decorations around all of the localized strings, and we have low resolution. If you're using an old simulator prior to, I think, iOS 15, the simulators ran WebGL really slowly, and so low resolution causes it to display at super low resolution, which makes it work better. It's still not great, but it's better. With current iOS, that's not necessary because the simulator runs at basically full speed. And that's pretty much it for the native code here. Document Picker, there's actually a lot of stuff here that I'm not going to go into, all the details that has to do with making it all work, but that's the native code. Now, in addition to the native code, we have a React app. And in this case, the React app is in our cross-platform directory of mobile samples. And in the source for the React app, we have a backend, and we have a front end, and we have a common. All iTwin apps do need a backend. Our backend is fairly small, and I'm not really going to go into it, but it's there. And then common is stuff that's used by both the backend and the front end, and then front end is the actual React app. And if we go here, I have Visual Studio Code running, and if this is actually running from the React app directory, just so you know, we have a tasks.json file in the React app that has various tasks, and one of the tasks is a build task. So if you do run build tasks, it runs the React app. And if we go back to the README, we can see running the samples. Well, in order to get things up and running, you have to configure things. Wait, let's see. This is yes. Okay. The npm has to be set up. Follow the npm setup instructions here, and you have to npm install, and you have to npm run build. You do need to npm run build, even though we're using the React debug server. The React debug server is a web server that runs on your Mac that allows you to much more easily interact with and debug your React app. And then we have npm run start here. It also mentions that you can do that from Visual Studio Code by just using Command-Shift-B, and which is what we have actually done here. It's running. You can see it down here. This is the React app. Now, if we go back to Xcode, I will real quickly actually run it. And I'm running on the simulator here, but of course it works also on devices. It takes a little while to start. I'm not quite sure why. And there it is. Now, I will really quickly show you the app. So we go into Hub iModels here. It needs to log in, which apparently it's done recently enough that it doesn't actually need any more information. And then we have a model. This is a model of a hospital, and this is our UI. Now, all of this is React, so it's running in the web view. All the way, well, all of this, everything you've seen, this is all React running in a web view. However, I mentioned that you have native components. If this ... if we tap it, we'll see that we get a standard popover. This is on an iPad. If we did this on a phone, we would get a menu at the bottom of the screen because this is an action sheet. And then this popover has like various different things. So like if I toggle the camera, we can see the camera is off now, and now this is in basically isometric mode instead of having perspective. And so this is an example of a native component being shown from the web view. And this action sheet is actually one of our standard components that we include with the iTwin Mobile SDK. So if we look at the React app and we go bring up its index, the ESX, you'll see that it's not doing a whole lot. We do have some weirdness going on here that's used for allowing us to have different samples all run on the same code base without really interfering with each other. But the what's happening here by default in this app is that it returns app, and so this is app, and that is this. And if we look at app, we can see it seems to be a really tiny function. That's because most of its functionality is in this use app state, which once again is done in order to allow us to be using the same code base for different samples, and all of the main sample code base is actually here, but it's not in the app component. It's mostly in use app state component. Now the app has multiple screens. We have home screen, local model screen, hub screen, model screen, and loading screen. You saw those screens in the simulator. Here's the home screen. It actually starts out on the loading screen, which I can't show you again because it's already gone. And then as soon as it's actually done loading, it moves to the home screen. Now, if what is doing on the loading screen, well, what it's doing is it's loading. So what's actually happening is there's a reuse effect that we have that gets called, and it gets called with these dependencies, push active info and initialize. Push active info is what we use to switch between screens, and then initialize is what we use to keep track that we have initialized, because we only want to initialize once. So if it's not initialized, we call set initialized to true and then initialize. We have this comment to disable floating promises because initialize is an async function, and we don't actually, in the use effect, we don't need to wait around for it. So we just have the comment. And so what it does is first it initializes a messenger class, and that's the class that's used to communicate between TypeScript and native. The very first thing we do after that is send a message saying loading, and as I mentioned before, that causes it to show the web view, which the web view has the loading screen on it at this point. Load UR search params, those are the parameters after the hash. And I mentioned the low resolution is one of them. Well, if we set that, then this is what that sets it to the low resolution. And then we actually go through the startup. These first three startups are part of the main iTwin. They're not mobile specific. Well, iOS app is mobile specific, but it's used on mobile apps. You use this for the initialization instead of using the other initialization. It's mobile specific, but it's not actually part of iTwin Mobile SDK. It's actually part of the base iTwin. Then we have UI framework and presentation. Those aren't mobile specific at all. And then we have mobile UI initialize, which is, of course, mobile specific. And we pass in the localization object from the iModel app. The iModel app was initialized as part of this iOS app startup. After we've initialized mobile UI, then we load our apps, localization namespace. We set have back button. That's used in one of the other samples, but it's from the hash params, and we don't have it, so it's not going to have a back button. That's on the main screen. To go back, basically it causes it to actually close the whole mobile UI. And then we send the did finish launching message to say, okay, we're done registering for anything that we were wanting to register for. Now, we don't actually register for anything here, but like mobile UI might register for things inside of itself. In fact, it does. And then we switch to the home screen. Push active info we have a stack of active info objects that tracks what screen we're on so that we can move back and forth between the screens. So that's this home screen. And then from the home screen, you can go to the local iModel screen or the hub iModel screen. The local iModel screen is for loading files directly off the device. And also, as you can see here, downloaded from the iModel hub, it remembers what files you have downloaded. I'm not going to choose a file here, but if I selected this, it would be the same hospital model that we saw the other way. And then the hub iModel screen allows you to select an iModel from the iModel hub. And actually, if you haven't already done that, it will start you on a project selection screen, which is here, select project, and then it has recent projects and whatnot. And so I have this project, and then the hospital model. And I'll toggle the camera again. So the hub screen and the local screen are for selecting an iModel, and then the model screen is what actually shows the model, which is this. It's the main UI for the app. And if we look at the model screen, this is the actual return value for the model screen component. And we can see that return an array of components. And that's because we want the main view, which is what the 3D thing is displayed in, we want it to be a sibling of the mobile UI content component. The mobile UI content component is a full screen component that has all of our mobile UI controls in it. And the viewport is also a full screen component that gets displayed first, but so it becomes basically underneath that. And we only display the viewport if we have a loaded view in it. If you can see, view state is a React state variable, and it's an async to load that, so it won't be available initially. It loads quickly, but it's not available at the very beginning, so we have to delay loading it. And then we also have mobile UI content, and once again, that's full screen. First thing we have in there is a navigation panel. And the navigation panel on the left, we have a back button, and then on the right, we have more button, excuse me. And so here's the back button, and here's the more button. And if we look at the more button, we can see that it's an action sheet button, which is also from our mobile UI React. And it has these actions, and there it is. And it has show status bar. It's a native component and a native view controller, and without show status bar, it actually would hide the status bar here at the top. And so if your app hides the status bar, then you don't need the show status bar. But if your app shows the status bar like we have, then you need that in order. Otherwise, when you tap it, the status bar will disappear, which you don't want. And if we look at more actions, we have, here are our actions. And if we tap on this, we can see we have show current location, fit view, default view, toggle camera. And so if we actually look at actions, we have show location, fit view, default view, toggle camera. And then the other thing is, if you look at this action sheet button, you can see more actions is not an array, it's a function that returns an array. And the reason for that is every time you tap it, it calls that function. So here we see we have 4 items. If I tap on this, it will select this roof here. And if I then show the action sheet again, you can see we have properties at the bottom. And the reason that works is, since more actions is a function that returns an array, it calls it every single time. And when you look inside it, we see we have those 4 set actions, but then we say, hey, if there's a selection set, then we also have properties. And so it adds properties to the list of actions. And if I tap on properties, we can see the properties for that item that we just showed. And then I can close it. And then if I tap out here, it will get rid of the selection. And if we tap it again, we can see properties is no longer in the list of possible actions. So that's the navigation panel. And then we also have tool assistance as the next object in our mobile UI. And that is this right here. And you can see it says identify element because that's our current active tool, is a selection tool. And so anytime you select on something, it's selecting it, and that's, you can identify another one. But if we look in this tools, we can see we have other tools available to us. So if I say section by plane, and then I tap somewhere on the screen. This is a virtual mouse, and it allows you to make precise selections. And so in this case, we're selecting this plane as a horizontal plane, and then we tap again, and it takes a little bit of time, but it's sectioning that by plane. And so you can't really tell too much, but we have this green arrow, and if I grab that arrow and drag it down, it will then be creating a section by where that plane is. And then if we go back into tools, one of the last tool is clear section, so we do that. It goes back to showing everything. Oh, I forgot to mention, but if I go back and do this, here it says identify point on section plane. And then when we do that, it's done. And then, yeah. So that's the tool assistance. And this, if we look at what this is, you can see that this is just a simple front-end component that shows the tool systems. We then have additional components, which there aren't any of in this sample. And then we have tabs and panels API, render, tab bar, and panels. If we look at tabs and panels API, we can see it comes from use tabs and standalone panels. That also comes from our mobile UI React. And rendering of that is all of this stuff at the bottom, tabs and panels. So tabs are all of these things. These are tabs. These are just like, this here is just purely as a sample. You would never do this in real life. We show the name of the iModel and we show the path to its file. Like I say, you'd never do that in real life. We have a about box, which is also just made up with the lorem ipsum text. We have the tools, which you already saw, and then we have views, which lets you to select views in the model. So like if I select this view, it is the default view in the actual model itself, as opposed to a view that we create at runtime. And then if we have an item selected, we have properties, which is a panel that's still, it's a bottom panel, but it's not one of the tabs. You don't see a tab for it. So how does that work? So if we look at this tabs and panels API, we set panels to panels, and panels is this array of panels, and it's an array of tab or panel def. So if we look, we can see the first one is info, then about, then tools, then views. And each of those has a React component that is a panel. And then we also have element properties. And you can see for element properties, is tab is set to false because it's not a tab. And for all of these others, is tab is set to true because they are tabs. And that is the whole thing, basically. Now, when you're developing these things, it's very likely that you're going to want to be able to debug. And to do that, and if you want to debug the web code, you'll be using Safari to do that. In Safari, under Develop, we have the simulator, and then we have this particular one. And if we open app.tsx, we can see we have app.tsx. And we want this one. And this is our app. And if we open up model screen, we see this. And if we put a breakpoint in the function that returns the more actions, for example, and I put a breakpoint right here, and then if we go back here, and if we tap on this, we can see that in Safari, our breakpoint has been hit because it's wanting to know what the more actions are. And if we step through this, I'm stepping over, so there's not really a whole lot going on. We can see we're checked to see if there's a selection, and if I step, we can see, oh, there isn't a selection. So if I continue, go back here, tap out here to cancel, select something. If I do that again, you can see that if I step through this, then now we do have a selection, which is of course what you'd expect, but yeah, so this is using Safari Debugger to debug the web view. Now, I don't know if you notice, if you hit Command P in Safari Debugger, it brings up a picker. And if I type, like, say, hub screen, it shows me hub screen. I would strongly suggest using this because finding the files is really hard because there's so many of them. I don't know if you noticed, but when I was like typing, if I type A, there's a really, really, really long list of files. And so it's just a lot easier to use the quick picker with Command P in the Safari Debugger. We'll close that. That's about it. And that's what I wanted to show you. That's our sample. Thank you very much.